Today, we will be having a look at how the techniques that we have learned can be applied to different problem solving. And this will continue from this lecture onwards for a few more lectures. We have learnt quite a few things. We have seen the overall structure of the C language. We have seen the if then else, if else structure, the iteration structure like the loops. We also know how the variables are defined. We have seen arrays, how data can be stored in one dimensional array and two dimensional arrays. We have also seen functions, and the most important thing about functions is that it enables us to take a complex problem and divide it into different parts and solve each of the parts separately using functions. A very important thing about functions is passing of the parameters and how the function returns a value to the calling function. We have also seen that there are two ways in which parameters can be passed from the calling function to a called function. One is call by value, another one is call by reference. In C language in general, always call by value is adopted. However, in call by value, we have to copy the value of the data, the parameter value to the argument value. However, for the case of arrays, whenever I want to pass a particular array, at that point an array can be a 100 by 100 array or 10 by 10 array. If it be a 10 by 10 array, then I will have to copy 100 values. So, that is not advisable. For that, we just pass the array name and let us quickly have a look that the array name is essentially an address, right. An array, whenever we pass, suppose there is an array, a two dimensional 10 by 10 array, all right, two dimensional array like this. Now, all the elements I am not passing. So, it is essentially it happened to be a 4 by 4 array. So, that is all the 16 elements I will not be passing. So, here is my called function, the function, called function, and on this side is the calling function. The calling function and the array name is say A. So, the calling function refers to, suppose let this function be called f. So, from the body of the calling function, whenever I am calling f, I am passing the array, say if it be an integer array int a, and here I just pass the array a, and here in this function body we have got say int a, and just saying that the size of the, or it may not be a, it can be x also, int x something, and the size of the array, and here int a and maybe n. So, here I am actually passing the name of the array, and the name of the array is nothing but the beginning of the address of the first element of the array. So, here I am actually copying the address. So, it is a call by reference in the case of an array. And in the last lecture, we have also seen that we can also use pointers to sort of establish call by reference. Another major thing that you have to keep in mind is that suppose this array is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now, these are organized in C in a row measure form. So, it is stored in the memory like 1. So, the rows first 2, 3, 4, then 5, 6 like that. So, when I refer to the array A, I actually pass on the address of the first location of the array. Okay. So, A 0 0 in the case of a 2-dimensional array points to this element, and that is this element. Okay. That is how we pass on arrays. So, for functions, and we have also seen some applications of all these techniques that we have learnt. In particular, we have seen how we can carry out search, and we have seen two search techniques. One is linear search, another is binary search. Now, in linear search, the complexity, the time is proportional to the number of elements, whereas in binary search it is reduced, it is faster, it is log of the number of elements to the base 2. And search is a very fundamental problem solving technique in because suppose you have got the names of students in the class, all right. Here are the names: Atul, Shyam, Gargi. In that way, the names are there, and each of them have got a roll number 1, 2, 3, 4 like that. Now, you want to find out how many Shyams are there in the class. So, you have to search this array and find out where Shyam is. Okay? Maybe here, and there is another Shyam here. So, that is searching and counting, both the things, but you cannot avoid searching this array. All right. It may be that along with that there is an array of marks obtained by roll number 1, roll number 2, etc. So, maybe this is 50, this is 70, this is 30. All right. Now, here tell me, I want to say, now they are in two arrays. This is one array called name and this is another array called marks of the corresponding students. Now, I want to know how much, what is the marks that Gargi has obtained. How do you go about it? What would be the first step in solving this problem? What is the marks that Gargi has obtained? In order to do that, I have to first, I do not know what is Gargi's roll number. If I had known what is Gargi's roll number, suppose Gargi's roll number is 3, then I could have gone in the marks array and I could have taken marks roll number, what if I knew the roll number minus 1, that marks I could have taken as a result, all right. But I do not know the roll number. If I had known the roll number 3, then I would have gone to the second element. So, its marks 2 would have given me the roll number. But suppose I do not know the roll number, then what should I do? First I will have to search this array, and what would be my key? What is my key? Key will be the string Gargi, because I want to know the marks obtained by Gargi. And what should I do with this key? I should carry out a search. It can be a linear search or it can be a binary search. Let us for the time being assume that it is a linear search. So, we will be searching and I will be finding Gargi here. I am assuming for simplicity that there is only one Gargi in the class. So, I will take this and I find what will the search, if you recall, what will the search algorithm return me? The search algorithm will return me the index or the position where Gargi is located, and that position will be actually it will automatically come, since this positions will be marked as 0, 1, 2, I will get this 2 returned. So, I get the key, I search the array name this is a character array, a char name, size whatever size is say n, and the key, and this search will return me the value position 2, pos equal to 2. Then I will simply take the value of marks, I will go to the array marks, pos, which will be my result, right. So, you see we needed the searching. Now, while I was talking of searching this array, I said that this searching I am assuming this searching to be a linear search. Would it be possible to search this array using binary search? If you just think it over, would it be possible to search it using binary search? What does binary search require? Binary search requires that the array be sorted, right, array be sorted. So, an array like this, Atul, Amal, Gargi and Joy, this is an array of 4 elements. Can I sort it? The type of sort, if I want to sort it, I will have to organize it in increasing or decreasing order. Let us assume that I am trying to do it in an increasing order. Now, this sort will be, this character array can be sorted in a way which is called the lexicographic sort. That means, I sort the character array according to the alphabets or the words as they are written. Obviously, A comes first. So, therefore, character A is smaller than character B, all right. So, here between these two elements, both of them has got A, but similarly T is greater than M. So, in this sorting I will first check between these, say A, they are same. Think of bubble sort, I am trying to compare them. In normally what we did, we found that say array x, xj is less than xj plus 1, and then we did something. If it is the case, no issue. If it was the other way round, I wanted to do a swap. But in this case, it will not be so simple. I can take a string and compare these two strings as to which one is, whether they are same or not, or whichever is greater. But another way you can write a small function to compare. I leave it to you. I leave it to you that you now know sorting techniques. So, you should try to write a function that will sort a string of characters. All right. So, A and A are same. If they are same, the function what will do? It will now look at T and M. Now, M is smaller than T. Therefore, Amal is smaller than Atul. So, Amal will come here and Atul will come here. Now, between Atul and Gargi, you can see A is smaller than G. So, Gargi is in a proper place. Now, if say for example, I do not have Joy here, I am having another name Gautam here. Now, when I am comparing between Gargi and Gautam, G and G are the same. So, they are equal, no change. Next, A and A are also same, no issue. So, there is no change, but R is smaller than U, because R appears earlier than U, but in terms of our computer code technology, the ASCII code of R is less than the ASCII code of U. So, in both the ways it is meaningful. So, R is less than U. Therefore, Gargi is smaller than Gautam. So, in that way I can carry out with another small function compare string is greater, say is, you can write a function is greater two strings, okay, char S1 comma char S2, two strings will be passed on this function, and this function will find out which character if S1 is greater than S2. It will just return if S1 is greater than S2. It will return a 1 if S1 is greater than S2. Try to write such a function. Okay. Now, that I am giving you as a home assignment, all of you should try to do that, and with a little effort I am sure you will be able to do that. So, I could have just as I had done in the earlier one here in this thing, I said that I will be doing linear search. I could have done binary search also, provided I had sorted them. Okay. Provided I had sorted them in the proper way, and then with the sorted array I could have done binary search. Now, we will be also doing some problem solving. In this course we will be doing some problem solving in the field of numbers or equations, mathematical problem solving. But before that, in order to do this, today let us have a relook at the strings. We had looked at strings earlier as an array of characters. So, let us have a relook at the whole thing today. How can I represent an array of strings like the one that I was showing here, an array of strings, all these names Atul, Amal, Gargi and Gautam, all these are nothing but this is a string, this is a string, all these are different strings. So, how can I represent them? Let us have a look at that. Say I have got three strings, one is Spike, and there is Tom, and there is Jerry. Now, these three strings I have to store, and I am saying that each string can be at best 10 characters, at most 10 characters. And I am looking at three such names. So, it is an array 3 rows and each row having 10 characters, right. So, the definition would be, I named them as CHR, I could have done character array, and it is 3 rows and 10 columns. Now, I can initialize that as spike as character S, character P. So, S comes here, P comes here, I comes here, K comes here, E comes here, and that is the end. So, it is \0. I also put that, and so 1, 2, 3, 4, 5, 6, 4 places are still vacant. Okay? 4 places are still vacant. Similarly, for the next one is Tom. So, T O M \0, and the rest 6 are all free, all right. But my string has ended here. So, one way is that I can represent them in this way, where I specifically talk about the characters in the array and terminate them with \0. The other way I can do it is simply I initialize them as 310, the same array, with 3 strings spike, comma Tom, comma Jerry. Now, internally, even if I do that, it is essentially becoming the same thing. Internally, it is being stored in the same way with 3 rows and each row having these characters S, P, I, K, E, \0, and so on and so forth. There can be more. T, O, M, \0, and so on and so forth. Here also J, E, R, R, Y, and so on, sorry, \0, and so on and so forth. It is being stored. So, both of them are equivalent. I can do it in either of these ways. All right. So, a string can be represented in any of these ways. So, we already know this again, the name of the array is a pointer to the 0th element of the array. So, if I have this array S, P, I, K, E, \0, T, O, M, \0, J, E, R, R, Y, \0. When I am calling that CHR, the name itself is pointing to the first element of this array. So, CHR 0 0, it is pointing to that. So, this and CHR 0 0 are the same, they mean the same thing. Okay. So, this you just like an array, this is also true here. Therefore, if CHAR points to the address 1000, CHAR plus 1 will point to address 1010. Why? The reason is again, I have got this array and CHARR is pointing, ARR is pointing to the 0th element of the first row. If this is 1000, then 1000 to 1009, this at this location is 1009, because the size is 10. Okay. Size is 10. So, although S, P, I, K, E, \0, etc. is there, then when I go to the next one, CH underscore R plus 1, that means wherever this pointer is, this entire thing is taken 0 to 10. So, I am taking here, it is taking all these 10 elements as one array, it will be pointing to the next one. That means, it will be 1010. Okay. Again, if I make it CH add plus 2, it will come to this one. All right. That is how the pointer works. But how can I get this character? This will be CH add 0 1, that is pointing to this element. Okay. Now, this thing must be clearly understood. So, CHAR points to a 0th string or the 0th one dimensional array. CHAR 1 points to the first string or the first one dimensional array, or number 1, 0th first. CHAR 2 points to the second one dimensional array. So, each of them are one dimensional arrays and CHAR is pointing to each of these one dimensional arrays. CHAR is pointing to one dimensional array, and as I increment the pointer, this pointer is going on increasing. All right. In general, CHARI points to the ith string of the ith one dimensional array. Clear. The following program, let us look at the program, and the following program demonstrates how to print an array of strings. Please take 1 minute to read this program yourself and try to understand it. You can see here that I am starting with the main function, and although it is written in a very cryptic way. So, my program starts from this point and ends at this point. I is an integer, CHAR is again an array of 3 strings and each can be of maximum length 10. So, Spike, Tom and Jerry are there. So, I can print, I just print first way, next line, I go to next line and to next lines. I just put first way, and then what do I do? So, I will print first way, and then 2 lines have been given blank. Then for I 0 to less than 3 I plus plus, printf string, I am printing the string. So, what will be printed? String equals a placeholder for the string, and then there will be some tab, one space, and then so the first will be string here, some space, and then tab, this is tab. So, I give some space and write address, and then string equal to address equal to, and there will be some space for the address, and that format is unsigned integer. So, it will become longer. All right. Because unsigned and signed integer, whenever I am putting, suppose I have got 16 bits for representing an integer. If it be a signed, if I distinguish between plus 5 and minus 5 and keep 1 bit kept for the plus or minus, then for the 16 bit I will be actually having 15 bits for this size. But if I make it unsigned, then I can have all these 16 bits. So, I can represent more numbers. Okay. All right, more numbers. So, that apart. So, string and address, and then what am I printing here? char plus I, that means 0, char 0, the first string, and then I am again putting the char this. Now, what is the difference between this char, this and this? This is being printed in percentage %s, that means the string will be printed, and here in an unsigned integer, what I am printing here is the address of that string. So, this string Spike was here, when I print this, just the name of the array, that means I am in this format. If I do, I am printing the address of it. Therefore, the output will be somehow like this. Okay. So, this is something to be understood very clearly, that this array, when I am actually looking at this, I am taking the content of the array, otherwise I am taking the array itself. So, here is a program. This program asks the user to enter a username. If the username entered is one of the names in the master list, then the user is allowed to calculate the factorial of a number, otherwise an error message is displayed. So, we have got a master list of names. Now, if you are a valid user, your name is there in the list. So, first what is doing is including stdio.h, it is including string.h, that means some string functions are also included. I am defining the factorial prototype, the factorial function has been written later. Suppose this part is later than the main function. Okay. Now, the main is here, and what is the main doing? It has got some integer I and found is 0. Initially, the name is not found here, and some n number for which I have to compute the factorial. Master list 5 by 20, that means each of these can be 20 character long, and there are 5 such, and I have put the valid names as admin, Tom, Bob, Tim and Jim. Now, I am asking a name is an, so I am asking from the user enter username. Now, the user gives the name. So, get s, here you are getting a new function being introduced here, that is get s. What is get s? Get char, get ch you know, and here get s means get the string. So, in one shot it is getting the string as the name. So, name I am getting from the user some name, say it is Jim. Suppose the user enters Jim. Now, for I equals to 0 to 5, why 5? There are all the 5 names are here. If string compare name and master list I, if this character, this string and this string matches, then found is 1. Otherwise, I am again going in the for loop. So, at every stage of the loop, I am trying to compare this name with this string. Here there is no match. So, I come here no match, no match, in that way I come and find Jim. So, here ultimately I will get found and then I will break. Now, when I come out, suppose it was not Jim, it was say Jimmy, all right, then I do not get a match here. So, I can come out with found equal to 0 or found equal to 1. If found equal to 1, then welcome, exclamation and then the name is printing welcome Jim and asking please enter the number, is entering the number for the factorial, and then here you see in this printf I have called the factorial, that factorial of the number is this, n is this. So, I call factorial, and this part you know now that this n and this n and may not be the same. I mean there are 2 different locations, but this n it could have been x also, in that case internally it had to be x here. So, this is being passed over here and the factorial is being computed. All right. Once the factorial is computed, now how the factorial is computed, I will be discussing that later, because here there is some trick. Forget about that trick now, I will be discussing that later. That is recursion, which we have not yet discussed, and after this I am coming back here and I am printing. So, the purpose of this program was to show how we can handle strings. So, this is a very common thing. I mean, you try to log in a machine, right, and you type in your login name and your password. If they do not match, the system says login failure. Now, how does it do it internally? Internally, it has got a list of, just like this, it has got a list of all the users, and it takes your username and checks it with all these. That is a problem that is being solved, a sub problem that is being solved in the operating system, and that is the basic principle is depicted in this program. All right. We will continue with other problem solving approaches in the future lectures. Thank you.